Hello, everybody. Hope you're having a great day. This is Maysam Mehralaran from Ozen Engineering. I've been with Ozen for almost a year and a half, and before that, I was 2 years with an electric car company called Python, and before that, I was 5 years with Ford Motor Company. This YouTube short is about turbo machinery. This is the sixth one, and it's mostly focusing on post-processing the results. A little about us: we have been in Bay Area for 17 years almost. We have 1,000+ happy clients. We have good amount of expertise in multiphysics FEA, computational fluid dynamics or CFD, and also electromagnetics, which covers both high and low frequency. And we have been ANSYS Channel Partner of the Year several times. This is our territory. We are in Oregon, Nevada, and California, headquartered in Sunnyvale, and also an office in Portland and staff in Long Beach. This is the list of softwares we can sell to you. We have mechanical, Elastina ENCODE on the structural category, and also on the fluid side, you have CFX, Fluent, Forte, and a lot more. On electronics, we have high frequency and low frequency, such as FHSS and also Maxwell, and a lot of other design tools, such as MotoCAD. On semiconductor, we have a couple of tools. On optics, we also have Optis, and in the material category, we have Granta. In the embedded software, we have different packages of Skate. And for system level analysis, we have Twin Builder, Medini. So whatever industry you're in, probably we have something that is relevant to what you do, and we can make your product development process easier. Feel free to call us anytime, and we would be happy to guide you to the right tool. This video is about the post-processing results. In previous YouTubes, we told you how to create the conceptual design, bring it into TurboGrid, mesh it, bring it into CFX, and solve it. And this is the last step, how to post-process the results. Post-processing has different categories. One is the quantitative results, and one is the qualitative results. Quantitative results are things like efficiency, pressure load, mass flow rate, head rise, and qualitative results, mostly results that you can see. You don't care about the value that much. It's like contour plots, vectors, path lines, animations, vector plots, etc. For quantitative plots, you can use the expressions, which is by default available in CFX and CFD Post. Or you can just go to the calculator tab, and there's a function calculator. You can do it just manually, which is pretty much the same thing, just different ways of doing it. And for qualitative results, we have standard options inside CFD Post, which is contours, vectors, streamlines. And you have some additional options when you're dealing with turbo machinery, such as, let's say, relative frame velocities, velocity, angle, vorticity, or orthoropy. These are things that come in and become active as soon as you have a turbo problem. And also on top of that, we have something called turbo post-processing. So we have some additional features in that, which is specifically for turbo, such as blade-to-blade plots, meridian or true flow plots, and turbo-specific charts that we'll be dealing with. If you are probably an expert, you definitely need these for design of the turbo machinery. Okay, let's go to the problem and try to do a short demo on it. Here is what we did in the last YouTubes. As I mentioned, we created a mesh. There was a fan with impeller and stator. We just did the impeller just for simplicity, but you can easily just drag and drop this part and do the stator part as well, but we just focus on rotor or impeller for now. We did the solution, it converged, and now we're going to post-process the results. So we just go to edit to open the CFD post, or double click on it simply. You see there's a turbo tab here. You have these results. This is the component as it is highlighted. You say initialize it. So it brings in the results. And then now you can see the okay, results are in. Now you want to see the results. For example, you go to 3D view. I would say select the hub and the blades. And then after that, you want to see, okay, I want to see the geometry. You see, this is how it looks like. You say, okay, I want to have even all of them. So you select area R1. I think this is 7 copies of it. If you apply 7, you'll see the whole CAD here. But as it's periodic, we just deal with 1/7 of it, which is simpler. The other thing you can do is create plots on blade to blade and meridional. If you look at the blade to blade, let's say I look at the domain I'm interested in. I click all the domains, and a span is the parameter that defines how far from the hub you are. If it's 0, you're on the hub. If it's 1, you're on the tip of the blade, or I would say almost on the shroud, and then 0.5 is like in between. And I would say I want to create contours of it. I plate. It shows how the pressure is in front and the back of the blades, as you see, which makes sense. It's heating the flow, so it's higher here and it's lower in the back. You can make it local just for different coloring. And also you can have even vector plots. You can define different parameters. It's all in your hand. Pressure, velocity. You can do vectors. You see there's some recirculation happening here. You can even create streamlines. It says the flow comes in and there is some recirculation on it. And also you have another plot, which is a meridional plot, which is flow around the like on the flow path, wherever the passage of the flow is. But the difference is that it averages that in circumferential coordinates. So you don't have the changes because of the rotation inside the circumferential direction. So let's say I pick a domain here and I choose, let's say I want to have the pressure shown. This is how it shows. This is almost the passage through which the air is getting in and out. And then you can even plot contours, vectors, and whatever you want. It's all in your hand. On top of that, there is some other capability also inside CFX. You can create 2D plots. Let's say, for example, you want to see around the blade how the pressure is changing. So we want to see is pressure on the streamwise direction. You can plot it 2D. The pressure goes up on one side and the other side it goes down. You can even see where these lines are located. You can change the span value to anything you want. Let's say you want to have it 75 roughly, which is much closer to the shroud and a little far from the hub. If you go to 3D view, you can even see exactly where these lines are located. This is the lines that we plot that 2D diagram based on that. So these are the turbo-specific tools that we have. We even have some macros for fan noise, some, let's say, circumferential property plot, and all these things that you can do. But on top of that, we have the standard way of plotting. Let's see if I select blades and also hub. This is what we have. I can plot typical contours also. I create a contour. Let's say a contour of pressure. And I wanna create the contour on the whole blade and just the blade and hub. You plot it, you see the pressure contours on it. What else can we do? For example, we can create even surfaces which are turbo specific. When you have a turbo device, some things add up to the location options you have. You can create a turbo surface. Let's say I want to have a span of 0.75. At a span of 0.75, you want to create a new surface, which is in this domain, which is right. Simply choose it. That's the surface we just created. You can even create plot contours of pressure on top of that. So you have all these extra surfaces. I create the span of 0.75. I choose it. Now I can see even pressure values on top of that. I deselected other parts. So blade and hub also needs to be selected. Apply. So you have all these capabilities. I think that was it. Also, you have the possibility to create like a report out of the things you have done. You can create a report, and when you publish it, it tells you like efficiency and all the other parameters that usually you deal with all kind of turbo machinery. Thank you. I think we're done with the post-processing. But if you're more interested, there's a lot of information on it I can share with you guys, or you can find it on AirLedge. So thanks for your attention. And hope you have a great rest of the day. If you had any questions, let us know and we'll be more than happy to answer. Bye.